5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hey, space enthusiasts. My guests this week are Ian Fichtenbaum and Chris Carpenter from Bradford Space. Bradford has been around for a few years, and their systems, such as propulsion and attitude control, have covered quite a bit of space heritage already. But they also have an exciting new project. Let's hear about it in this episode. My name is Raphael Rodkin, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with their CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu. And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast, and we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space. Hey everybody, welcome back. It's another episode. Today I'm thrilled to have Bradford Space on the podcast. And not just one, but two of them, Ian Fichtenbaum, the CEO, and Christian Carpenter, the head of production and advanced systems. Welcome, guys.
Thank you.
Oh, thank you. Thank you for having us.
So, Ian, since you're the CEO, why don't I ask you if you could give a quick elevator pitch about Bradford, please?
Oh, certainly. And thank you for having us on. Bradford, in a nutshell, is a space infrastructure and mobility company that is enabled by proprietary propulsion and avionics and attitude control technologies that we build in-house. We, as a company, have a few different heritages in terms of our history because we didn't start off as one company. It became one company after a few acquisitions. The company today, it's a multinational, we would say, powerhouse in propulsion, mobility, and space infrastructure. We're located in the U.S., the Netherlands, Sweden, and Luxembourg, headquartered in the U.S., but operations on both sides of the Atlantic. And it's this geographic distribution, our heritage serving customers all over the world, commercial and government, and our plans for the future in space mobility and infrastructure is why I'm extraordinarily excited about our company. As a CEO, you always have to be excited, but we love the things that we have done. We love the things that we're doing, and we love what the future holds.
Terrific. And I have to ask, so many space companies have very stereotypical names, as something with Stella or something like that. So Bradford is a little bit different. Can you just give us the quick story behind the name?
Well, I don't know if there's a quick story. The story, I think, in a nutshell, so our Netherlands unit, our Netherlands operation, that's actually a company that has existed since the mid-'80s. It was entrepreneurial company in the 80s, doing first nuclear, then things in the space. The story about that is that the original founder was looking for a place to locate their business, and they found a factory, an open factory, an empty factory in the south of the Netherlands that had belonged to of all things, a socks company, a textile company, that they liked the name. They transformed it to Bradford Engineering, and that's how it was for the few decades after that. Now it's still Bradford Engineering, but in the process of the last few years, it became something much bigger. We say Bradford Space instead now than engineering. But Bradford Space, the name has been adopted, and through all the rest of the units of Bradford. Now, I do want to make one very interesting point, and I like pointing this out, because if you go back farther to the origin of the name, we don't know the details, but obviously there's a town in England with the name of Bradford. If you look at where that comes from, you have to look into the origins of Middle English and just break down the name. Broad means far or wide, and ford means to cross. It's something of an interesting thing. A wide crossing has a little something to do with space, and especially our focus now of deep space. It is appropriate.
That makes sense. Yeah,
it makes a certain sense.
Back to the roots.
Yeah, you have to explain it a little bit, and all things considered, names shouldn't have to be explained. But it's a name that has a lot of good history behind it. I think it's a name that has a great future ahead of it. And there's some nice gems in the name origin.
It's already quite a story. So what I basically, as I can summarize it, it's socks to nuclear to space and not to deep space. Which is
bridges to socks to nuclear to space. So
there you go.
It's a roundabout road.
What's your background? Have you always been in the space industry?
I've been mostly always in the space industry because most of my career has been advising companies or investors in the space industry one way or another. I came from engineering. I came from operations research. I spent almost 6 years with an investment advisory firm. So that was advising mergers and acquisitions and financing. That was primarily for satellite and space companies. It's from that I got into business, also in bringing companies together, growing them. That I found myself in the position I am today, where we've brought this group together. To be one company to build out the solar system. That was a sort of a bio that brings it back to the company, but the too long didn't read version is engineering and finance bringing me here.
Understood. So let's turn to Chris. Chris, what's your story and why did you decide to join Bradford?
Yeah, so I've always wanted to make a difference, to do something that hadn't been done. When I was in college, I thought I wanted to go fly jets in the military, and went into aerospace. And as I was studying, I found that UAVs were going to be a thing, and pilots were going to not be in the cockpit as much. I didn't totally understand how slow the aerospace industry moves at the time. So I thought, okay, this is, I'm not really going to have a chance. So I ended up finding electric propulsion in my studies and decided that I wanted to bring electric propulsion to the world. There hadn't been much done at that time. So I got a job at NASA Glenn Research Center, working on ion thrusters, gridded ion engines primarily, and also working on a space station. And then was there for about 5 years. And the last thing I did at NASA was start the life test for the next ion thruster, which became the longest life test that's ever been done for those type of engines. Then joined Aerojet Rocketdyne and was there for 10 years working on Hall thrusters, NASA's Orion program, advanced architectures for space transportation. And the last thing I did at Aerojet was the CubeSat propulsion system that was 3D printed. And it was the first time anybody had done that. And the company won the most innovative company in space for 2015 from Fast Company in part for that project. And then joined SpaceX after that to develop the Starlink propulsion system, which is now flying on about 2,000 some odd satellites. The number keeps changing. And at that point, it was sort of like, hey, this happened, accomplished what I was there to do. And I was looking for what's next. What do you do after this? And so Ian called me up and said he wanted to do something in deep space. And I said, that's cool. I haven't really done that before. I think that's an area that needs new technology and a push. And so I joined Bradford to help push us out into deep space.
That's a terrific story and really great experience. So we want to talk mostly about Bradford today, but I just have to ask you, so Aerojet to SpaceX, it strikes me as sort of like culturally different organizations.
Oh,
just
for sure.
Couple of minutes of sort of like high level how they can compare some of the things that immediately come to mind.
Yeah, absolutely. So it's been a great privilege to have worked at NASA, which was obviously governmental. Work at Aerojet, that's kind of a hybrid between commercial and governmental, and then work at SpaceX, where it's obviously they serve the government, but it's highly commercial and highly high speed, high energy kind of thing. What I found is that, and I won't run into too much time on organizational structures, but there are pockets of innovation still within NASA. NASA continues pushing things forward, but there's these little pockets that are really what's driving everything. And I had the privilege of being a part of one of those teams when we worked on the next ion thruster. And then when I went to Aerojet, I found teams that were trying to innovate, and there's a lot of pressure to stick with heritage, not only from internal management things, but also from their customers. And so in many ways, they respond to their customer needs. And if your customer wants heritage, that's what you're going to do. But there were pockets of innovation there, and there were decisions made by the management team to continue innovating. And when I got to SpaceX, I just found more of that. Their leadership wants to innovate, so they make a choice. And that's what I like about being here at Bradford as well, is that Ian made a decision that he wanted to push the company forward and innovate, and that I wanted to do more of that.
Terrific. Makes a lot of sense. Okay, yeah, as I said, back to Bradford, which is the main focus today. So I saw a line on your website which basically said I think it's the most capable space company you've never heard of.
We hope that changes, but more the second part of that line than the first.
And that's, I think, hopefully today is going to help start changing the second part. If you want to change that, of course it is. But let's pick that apart. Let's start with the first half. So the most capable space company, very capable space company. So can you talk a little bit about, and you've mentioned a few things like avionics and propulsion, but can you talk a little bit more detail about the capabilities you have and the space heritage you have?
So capabilities we have, just broadly speaking, we have about just over 80 staff worldwide. Though the majority of our operations are in Europe. So a lot of that capability is Europe-centric. I'll get to the U.S. and Christian's work, of course, but the European infrastructure works on a lot of high-quality components and subsystems and even full propulsion systems. So a lot of things. Spacecraft depend on a lot of subsystems, but we build attitude control systems, and that's sun sensors and reaction wheels. We build propulsion subsystems, starting from pressure transducers and flow control systems up to full propulsion systems. And full propulsion systems are considerable things: the thrusters, tankage, feed systems. A lot of elements that go to that, and it's very critical elements. So we do that in our facilities. We have a great capability to build those, but beyond just the engineering and the build, what I love about our company is that we have a production mindset. And that is rare in the space industry. There's a lot of companies that do R&D. There's a lot of companies that do custom one-offs, and we do both. We do those things, but there's not as many companies that do production right. And that's where Christian coming to us was a big deal, and what we thought was a great match, because we have had the mindset of production and quality production, where we have had standardized product that we build in the quantities of dozens and in some case hundreds. That's quote unquote high volume for the space industry historically. Yes. We don't, by the way, consider that high volume in the context of the world. But we have that basic capability, and it includes also building thrusters. It includes test fire facilities. It has ability to make propellant for our systems. We also have a growing capability in avionics. So in the spacecraft control systems and other elements that will be included in people's vehicles, including, we hope, our vehicles. In the U.S., of course, Christian and his team are doing things to advance our systems on a vehicle level. He's tackling problems in power, in computing, in robotics, including and on system design, vehicle design. So we think if you have good or great proprietary technology, we think if you have an infrastructure, we think if you have a great team, we think if you have good customers, and importantly, if you have a design for manufacture and manufacture mindset, you can do great things. So when you combine all these things, and it comes together in the scheme of things, we're still a smallish company. We're not a few people in a garage, but we're also not the big aerospace companies of the world. We think if you put all those things together, you have one of the most capable companies that I think if we're after this podcast, it won't be as applicable anymore because more people will heard of us. But I think we're great capability and growing capability.
You mentioned the sort of the production side of things, and sort of going from a traditionally very low volume number in production to now relatively higher volume numbers. And I totally agree with you that we're nowhere near what's called mass manufacturing in other industry segments, right? That's something I want to ask you about anyway, and because it's interesting that shift is now starting to happen in the space industry. You would probably agree it's not necessarily trivial. I think Elon is on the books. He has once tweeted that something like building one prototype is really easy and mass manufacturing is really hard. And I just wanted to hear a little bit more about how that's happening at Bradford and how you guys are thinking about it. And I guess it's also where Christian's specific expertise comes in, because I assume that the Starlink production line is the highest volume sort of space-related production line in the world, probably going at almost 200 a clip per month or something like that. How are you thinking about this? How are you thinking about implementing it at Bradford? What are the challenges?
I'll take that one. So when I was talking with Ian coming into this role, one of the things I mentioned to him was that building one satellite has been the norm for a while. People build one flavor, one unit or maybe a couple units, and they don't design a production system to be able to make more of them. And when they do that, they end up paying over and over and over again for the same capabilities. And so if you design your satellite to be manufacturable, even if you just make one or two, you end up paying that off very quickly. At least that's the theory here. So we're looking at how to design a satellite to be manufacturable. And this is very different than what SpaceX is doing because of the propellant we use and the missions we're trying to go after. But there are a lot of general lessons from manufacturing that apply here. You really have to design a manufacturing system from the ground up. You have to design your product to be manufacturable. You have to have IT infrastructure that supports low labor, low overhead of running the production system. A lot of companies are spending enormous amounts of labor just tracking the information. And how do you address that? When you're looking at building things at these scales, it's quite challenging because you cannot justify the machinery that you could justify for very high volume manufacturing, but you also can't burden yourself with all of the labor associated with a one-off build. So you have to find a way to bridge that gap between, high volume and a single unit type manufacturing. And that's extremely challenging. And so that's the kind of thing that we're trying to address here.
And then what do you think? Does that not mean also that at least in the current state of the space industry, you basically have to do what SpaceX has done and what it seems like you guys are also doing, that you have to be relatively vertically integrated? Because, you can be optimizing your own production line as much as you want, but if the rest of the supply chain is such that, I think at the satellite conference last week, one of the panelists said, he was quoting an example, like he ordered a reaction wheel and he had to wait for like 9 months to get the reaction wheel.
Right.
So if that's the case, right, then obviously that doesn't work, right?
Yeah, 9 months is probably a pretty decent delivery schedule, actually, in the aerospace. A lot of things are 18 or 24 months. But you're absolutely right. What happens is, and where the innovation occurs, is knowing that you're dealing with these sort of lead times. You have to get creative and find ways around that problem. So even back at NASA, I ran into this where we had to get material. And I had one scenario where we needed a large amount of material within 48 hours. And the procurement cycle, just placing the order, was usually more than 48 hours. And so I had to get very creative with how do we procure this thing and get it here. And we got it. We had within 48 hours, we had what we needed. But you can't use the normal systems. You have to get creative about it. So the vertical integration needs to be done at the right level. There's a lot of things that you don't need vertical integration for. If you can, the way I look at it is, if you can explain your requirements simply, if someone else has an existing process capability to make something for you, then it's a good idea to leverage that. The place where I look at vertical integration is when you have something that's very complicated to communicate, or where you have a supply chain with a past history of delivering late or delivering poor quality. Those are areas where you may want to insource. I think that may be a little bit different than how people view the concept of going full vertical, but that's really where it makes sense to me, is in those scenarios.
That makes sense. And last question on the sort of the production process. We've been basically talking, at least implicitly, only about the hardware side. I guess there's a whole software side to spacecraft as well.
Oh, yes. Yeah, absolutely. Your hardware, software, your electrical, all of that needs to mesh really well. The way that I look at it is to try to modularize way the parts interact with the factory. So everything that you make has an environmental interface, a mechanical, an electrical, and a human interface. And the human interface may be fairly minimal, but it's, how is the human interacting with the data in many cases? And so you need to break those up in a way that they don't interrupt each other, and that they play harmoniously with each other. And that is something that is a technique developed over time. In a lot of cases, there's some trial and error with that. But I try to keep those interfaces very separate from each other. So Whereas a lot of people that I've seen in the past will integrate those things, and then it makes it very hard for them to be flexible when a design changes. So as an example, if you have, let's say, a hot fire test chamber, and you build into that chamber all of the electricals for a given rocket engine, and then your rocket engine changes, you now have to do a lot of tear up of that test facility to be able to accommodate that new rocket that's coming in. Whereas if you keep those things modular, you can basically roll up a test rack that's specific for whatever rocket engine you're firing that day. And if your electrical interfaces are very simple, it's pretty quick to make the changes. And I've been able to demonstrate that concept time and time again. But I've seen a lot of people that integrate things in a way that are very challenging to make changes. So keeping those interfaces flexible and modular is really key to making all those things work together. And that includes data and mechanical as well.
Understood. Cool. I want to spend a few minutes talking, coming back to you, Ian, about overall strategy, because you have this interesting history that you're, like you mentioned, you're an amalgamation of, I think, if I remember correctly, 3 different companies.
Yes.
Who have many different, very high space heritage, proven products, different types of products, as you mentioned, avionics, propulsion, and so forth. How does it all fit together? How are you guys thinking about, how the pieces fit together and how you sort of extract long-term value from that?
Well, the commonality starts with the propulsion and mobility. This is our largest area of capability, knowledge base, of technology, and this is from where we're growing. And for the next phase of space development, even the current phase, but the next phase of the development is the space industry, so much of the value is going to come out of the propulsion and mobility, because so much of what we're going to be doing is either going out beyond Earth orbit or doing more things in orbit, whether it's rapid rephasing or satellite servicing or removal activities. All these areas where propulsion is going to take on a greater role than it has in the past. Or in the past, it's been station keeping and place into orbit, all very important things. But as we go out, there's going to be more value in propulsion. So in our company, we have some strengths. We have a high performance green monopropellant that is the basis for a lot of our highest performance propulsion systems. We also have the water electrothermal, the Comet propulsion, and that is also on a couple dozen satellites. So is the green monoprop. We also have experience with electric propulsion. Obviously, Christian with an enormous amount of experience electric propulsion. But we also have in Europe cold gas, bipropellant. We believe if you master a suite of propulsion technologies, you can master mobility in space, and you can be a force in the coming space industry. So we're already good a good way along the way. We already have part of that suite. We're already planning out how we have the rest of that suite of propulsion technologies. And if we bring them together in an affordable, highly integrable, multi-mode space platform that we can produce at quantity, we feel we can be an integral part of the infrastructure of what's next. What are the spacecraft that goes outwards? What are the spacecraft that does things in space? That's where we get very excited because we have the common elements. It can't just be propulsion, but if you have all those elements of propulsion, then you can build out the next things. You can build out the platforms, and then that can flow into the networks. That is the infrastructure. That is the vision that we start off with. Have the full suite of the best technologies propulsion and build on top of that, but build it with design for manufacture and production and low cost and utility to the customer in mind. I don't know if I went off track in the question.
No,
if I missed anything, tell me.
It actually makes sense. It sort of like explains, how the different pieces fit together. And let's continue that and explore it a little bit more in detail. What exactly sort of like this next generation, spacecraft could look like, to the extent you can talk about it. I just want to sort of ask one follow-up question. Sort of, you've been talking a lot about sort of, efficient. I forget the exact words you use, but basically efficient space transportation and also like low cost and everything. I mean, since basically all three of us are quantitative people, you and I, finance people, and Christian, an engineer, is there sort of any metric you guys use? Is it, I don't know, it could be like dollars per delta V or something like that, or how do you look at that?
That's part of it. People are looking for unit costs, so they're looking for an entry point that they can afford, but they're also looking for value. So if we provide the same value that would be in the hundreds of millions of dollars spacecraft, now that's a government market. We have to be careful about that. A lot of people have made that argument as well, but it's not. You usually don't make that argument in a one-for-one. The argument is usually you can get X more capability. You can send a fleet. You can have a whole collection of space telescopes. You can have a network capability. You can have a cluster capability. So that's how those discussions happen, especially on the government level, where they see it on a capability and some part an industrial level. For newer applications, we again, cost of entry is important. Cost of being able to integrate onto our platform. Availability is also a huge thing. Availability is driving so much of the industry right now. We see it on a component supply. We see it on a vehicle level. People want things now, and that often doesn't comport with needing to wait 18 months for your reaction wheel. So part of our plans is to try to solve that.
And then this sort of new mode of space, this new vehicle you're talking about, if I heard it correctly, it basically would be something like, I was going to say an OTV, an orbital transfer vehicle, though I guess, once you have all this propulsion, it doesn't necessarily need to be confined to the orbits. It could go to the moon or other places as well. But is that the type of thing you have in mind, like an in-space transportation spacecraft?
Effectively so. It can do transport. What it also really can do is transport your function far or around, from orbit to orbit, or mobility. I mean, it's always orbit to orbit, but is it transiting to some different orbital domain, or is it maneuvering around in that orbital domain? And this is about both. Now, there's an additional element to what we're trying to build, because we're building this initially with our green monopropellant. It's chemical, and because it's chemical, it's high thrust, and because it's high thrust, it's fast. And speed is important for a lot of applications. It's important for rapid reaction. It's important for moving through the radiation belts quickly. There's a lot of reasons, a lot of value to have speed. It's a trade. It goes back and forth. There are a number of different applications where speed is not so important. You want payload capacity instead. You want to be able to get there. So it's not going to be all about one particular propellant. We are starting with the green monoprop. That's the basis of our vehicle, which we call Square Rocket, SR Square Rocket. But we hope it's going to be a whole line of vehicles that do mobility.
So once you have a vehicle like that, like you said, with chemical propulsion, which has a lot of thrust. I mean, there's actually a range of obviously imaginable use cases where the thrust comes in, and the capability of moving relatively rapidly between orbits or even to the moon, right? I mean, you could do things like debris removal if you wanted. You could obviously do the last minute delivery of other people's spacecraft. I guess you could even do sort of like really specific tasking, like reconnaissance missions, things like that. Yeah. How are you guys thinking about the market, and is there any sort of use case you guys are more excited about than others?
Well, and I would even say not only are we going for fast, we're also going for far, because we're looking at not only at high thrust, but high delta V at the same time, which is, it overlaps some of the activities they're doing in nuclear. Obviously, nuclear has a lot of capabilities, but here we're talking about chemical, which overlaps a lot of those capabilities without some of the the known downsides of nuclear. Yes, we see all these possibilities: debris removal, network deployment, rapid reaction, high resolution imaging. When you go very close to the Earth or very low orbits, you have drag, and that's where propulsion becomes very important. So VLEO, very low Earth orbit. It's a very interesting area for these vehicles. But also going to the moon. It's not just the getting to the moon, which does require a lot of delta V's. You can be on a translunar injection launch, so you can get there. But a lot of the orbits around the moon, near the moon, require a lot of delta V. They require a lot of station keeping, because it's a lot of orbits there are unstable. So the more delta V you have, the more you are able to conduct operations, or more lifetime you have. Of course, on the far argument, going out to Mars, going out eventually to asteroids, there are certain limits, for the if you're limited to certain sizes. But as we grow the vehicle, and we grow the capabilities, all those things are in reach.
And some of the use cases we've mentioned, like, for example, the active debris removal, or another one I didn't mention before, I just thought of, is I guess you could also take spacecraft to and from refueling depots, right? Which, of course, some other space startups are working on. They require additional capabilities that we haven't specifically talked about, and I don't know whether you have them in-house, which stuff like rendezvous, proximity ops, docking, robotics even. Is that something you guys are looking to do? Are you looking to do it in-house? You're working with partners?
I think our answer is both. We're looking at partners. We're looking at what we're doing in house. I think robotics and proximity operations. It's a rich topic, and we're only very barely beginning this topic in the space world. I mean, you have systems that do this, but you imagine an ecosystem. You imagine a space economy where people are going to space stations, people are servicing spacecraft, people are moving back and forth. There's a lot to work to be done. It's a very rich area, and we have some things we've identified as increasing capability and lowering cost, in a few cases immensely. I don't think we're ready to talk about any of these things publicly, but there's going to be no shortage of innovation in this area.
And what is the status of this project? When do you expect this to fly for the first time?
Well, Christian has takes a lot of his experience. Of course, we take our experience. We're doing our development for qualification within 2 years. Effectively, that means a flight within 3 years. We've done a lot of work. What's really great about our work on the vehicle level is that our core propulsion is in space already. We produce it. It's flying on 25 spacecraft today in orbit, and so we're not starting off with a technology that you have to test first and fly first. It's something we already make. It's already flying, and we have to scale it up. We have to integrate it on a vehicle level. That's our challenges right now. We have to make it a reliable vehicle. We have to design for manufacturing and production. Those are the things that are the challenges. If you wanted to put together just a vehicle, we could probably put something together within a year, but that wouldn't get you a service, and that wouldn't get you something that's economically interesting, either for us or for our customers. That's the power. to get something that serves logistics in space, serves all the applications for mobility in space, and do it affordably and do it effectively. That's what we're really excited about here.
So thinking about this sort of going forward, so like if all goes well, you know, in 2024 you have a first flight, but of course it's not enough to have, you know, one first flight. Especially what you're trying to do here again is going towards relatively more mass manufacturing, because of course you're only going to get those economies of scale if you actually really end up mass manufacturing, right? I mean, you can have the best designed production line in the world, but then if you don't actually sort of use it at its high capacity, then you won't get the economic benefit. So which means you need to actually produce and deliver a lot of these spacecraft, which kind of goes back to use cases and have, you know, being comfortable that you can deploy a lot of these spacecraft. I mean, it's the same, of course, in SpaceX. SpaceX sort of, they basically almost cheated, right? Because they invented their own use case with Starlink, and that gave them a reason to produce thousands of satellites, which gave them a reason to, you know, launch a Falcon 9 almost every week by now. But sort of how would that equivalently look for you guys to get to those numbers?
Yeah, I'll take that one. It's so let me explain it differently. I think people have sort of misunderstood a little bit about the value proposition of these things. So if you're going to try to deliver internet to the world, you want to minimize your capital expense for everything that you can, obviously, just like any other business. Mm-hmm. And so as a result of that, you want to make things cheaply. And if you can't find anyone to make it cheaply, then you need to go do it yourself. It turns out that for satellites, the concept of launching lots and lots of satellites to get the price point down is not as powerful as people expect it to be. If I go design a spacecraft that's very expensive and I make 1,000 of them, they're still going to be expensive. So you have to start with building a spacecraft that's designed to be low cost. And that's what we're doing here at Bradford. So we do not have a requirement to launch lots and lots of these satellites to make them cheap. They're going to be designed to be cheap, even in very low quantities. And I predict that what you're going to see in the satellite market is you're going to see a lot of companies that believe they can solve the cost problem simply by building lots of vehicles. And I would argue that is a way to lose a lot of money very quickly. Mm-hmm. What you actually need to do is design the satellites to be cheap in low quantities and then scale that up. And that's what we're doing. So this satellite is an architecture that is designed to be low cost. It's designed to be flexible to change. And that is going to result in low production costs regardless of scale. Certainly, we would like to make more of these. The initial, capability is not going to be anywhere near, what Starlink is doing as far as
sure.
because the market won't justify that. So what you want to do is on a factory level is build a factory that can make a small number of units very cheaply, and then be able to scale that capacity up without massive capital expense. And that is a very hard problem to solve. And especially for what we're doing, because of going out into deep space, it's extremely challenging because we also have to have the ability to survive, some duration in deep space environments that are quite harsh compared to low Earth orbit.
Yeah, this is a very subtle discussion here, because many people think factory means high volume, or you do volume for volume's sake. The factory is linked to our ability to build the craft of the needed design, where the software links with the elements of the spacecraft that come together. That doesn't exist in a one-off custom environment. And it may not even necessarily exist in a high volume circumstance, although I would assume somebody builds out a factory with that in mind. But it is a place or a set of facilities from which you could build this at a reasonable cost, even at relatively low volumes, with the flexibility of going higher. I'm repeating some of what Christian is saying, but it's a very subtle way of thinking about this.
Okay, understood. Let me ask you one last sort of, I guess, strategic question, Ian. So in the past, you've been, if I understood correctly, basically component suppliers, right? For example, of propulsion systems or avionics systems. Now you're going to have an entire spacecraft. Of course, there's two options, right, which are not mutually exclusive. You could sell that entire system to other people to operate, or you could operate it yourself, right? It's sort of the old aviation comparison. Well, are you an aircraft manufacturer or are you an airline? Which I think in the space industry hasn't been answered that much yet. But how are you guys thinking about that?
I would say there's a lot of good operators out there who are skilled at operating the end network or accessing the end users, whether it's telecom networks or imaging systems or space service providers. I think in the very large set of cases, probably the best thing for us is to be working with those operators. It's a big enough challenge to get the manufacturer right, to then also have a go-to-market channel or a sales channel that goes to a comms market or an imaging market or any kind of any other market is also going to be that much more challenging. So I think today, what we want to do is partner with a lot of operators out there. Now, that isn't to say and there are probably some use cases which are new and unique, where we will have to be the operator, almost by necessity, because it will develop organically out of what we're building. We're girding ourselves the possibility that will happen, but I think our first preference is to work with operators. If any of those operators are listening, of course, we're open to reach out or open to discussions. I think that's our default case.
In addition to that, I think it's a very interesting problem that I haven't seen anyone solve yet, which is the ability to have a satellite that's flexible enough to support multiple different kinds of payloads for different kinds of customers. And so I would be very excited if this vehicle ultimately does solve that challenge and allows multiple operators to run off a common, not a common bus necessarily, but from a common platform, common architecture. And so I'm trying to design this factory to be able to build our satellite as well as other types of satellites. So if someone comes in and says, hey, I need to build, 6 or a dozen or more satellites, can you do that? I'm very interested to see if we can make a factory that is flexible to which satellite we're building, and also be able to have this core offering of a satellite that can support multiple customers. So in that regard, we'd love to see operators and people with, constellations, small or large, come in and work with us to develop those.
Terrific. Yeah. So Ian, let me ask you to sort of maybe tie it all together and summarize sort of what's your vision for the company sort of 5 to 10 years out? What would you like it to look like ideally if all goes well?
Well, I'd like us to be building these vehicles. I'd like us to have the full suite of propulsion, as I mentioned earlier. I'd like us to be building out the infrastructure of the next step of space development. Some of it is in Earth orbit, and I think a lot of it is going to be beyond Earth orbit. Some people talk about cislunar. That's going to need a whole infrastructure. But as we go out to Mars, and this to me, if Elon and SpaceX are going to Mars, there's a lot of infrastructure that's going to be needed, and it's going to need this high mobility. So if we can play in that, if we can be the critical provider of navigation or communications, surveillance, reconnaissance, just throughout the solar system, that's a pretty impressive vision, something to be excited about. I think as we go out and you think about, if you're able to do that, then a lot of the talk about asteroids, space resources they seem more doable. They seem more real as you go there. But I think there's a lot of markets all across the board there's a lot of things to do. So we're excited about everything from very close to the Earth out to at least Mars. And people are going to need the building blocks, and I'm hoping we're the building blocks.
Understood. And it's funny you mentioned asteroid. That's because, of course, you guys, one of the companies you bought was Deep Space Industries. So again,
Yes.
It's sort of going back to the roots.
Going back to the roots. I mean, they realized that if you want to go do it, you have to get there. And a lot of their activity was, what's the craft? What's the spacecraft that gets you there? And when we took over, we said, well, this and when we took over, we were able to pair it with technology we had, propulsion technology we had, and that's one area where, is that word synergy. We saw there was a value between the marriage of our propulsion technology with the idea of high mobility, deep space spacecraft. So there's a lot more uses for these kind of things than just going out to the asteroids, as we realize. But once you do those things, you can go out to the asteroids. So you're right. It's full circle.
Yeah. So speaking of asteroids, that's a very nice segue as we're winding down here. Last couple of questions. So first question and the last questions are always for both of you. First question is sort of, besides what you're internally doing at Bradford, just one sentence really rapidly. What are you most excited about that may happen in space in the next few years?
I think LEO space stations are going to be huge. This is my opinion.
Well, obviously I have to say Starship. But then after Starship, I agree with Ian. And I've told him multiple times, I think we're going to see a state change in LEO operations where we effectively extend the yacht market into space and extend the cruise line market into space. And I think that's going to happen a lot faster than people realize.
Yeah, fully agreed.
This is an area. It also connects to our mobility thesis. There's more infrastructure that you need for it because it involves people.
Yes,
but we're watching it very closely, and I think that's going to be very, very exciting. I think.
And I would just add to that these vehicle we're developing right now is an architecture, and the factory we're developing is an architecture, and that architecture is scalable up or down in physical size from what we're doing today. So as those markets emerge, we will be very excited to see that and ready to respond.
Good. And then from moving on from space stations and Starship, it's an easy second to my traditional last question, which is about science fiction. Again, to both of you really quickly, do you like science fiction, and your favorite science fiction movie, book, TV series, whatever?
Well, I grew up with Star Trek and Hitchhiker's Guide to the Galaxy. So I grew up in that milieu. I would say the one science fiction that I've gotten into lately is a show For All Mankind it's an alternate history I find fascinating because it's kind of close to home about what space development could look like with a little extra jolt that I think we're getting now anyways.
That's certainly true. Christian?
Firefly.
Excellent. Oh, very traditional choice. Very good one. Well, on that note, guys, thank you so much for coming on. Best of luck with development of the new vehicle at Bradford. And, maybe we'll do this again in a couple of years and see how far you guys have come.
Thank you.
Yeah. Give us a ring.
And that's a wrap for another nominal episode of the Space Business Podcast. Once more, if you enjoyed this, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. You can follow us on Twitter at podcast_space. You can support us at www.patreon.com/Space Business Podcast. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an interesting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. See you for the next episode.